Good day, everyone. Today, let's take a look at an application of derivative in the business world. Let's have an optimization problem that focuses on an apartment. So, here's an example of business application. An apartment complex has 250 apartments to rent. If they rent X apartments, then their monthly profit in dollars is given by P of X is equal to negative 8x squared plus 3,200x minus 80,000. How many apartments should they rent in order to maximize their profit? All that we're really being asked to do here is to maximize the profit subject to the constraint that X must be in the range of 0 to 250, or X is greater than or equal to 0 but less than or equal to 250. First, we'll need the derivative and the critical points or point that fall on the range X, which is greater than or equal to 0 but less than or equal to 250. Based on the problem, the given function P of X is equal to negative 8x squared plus 3,200x minus 80,000. The derivative of this one is negative 16x plus 3,200. This is using the power rule. Now, we will use the derivative of the function to find the critical point or the critical points. Negative 16x plus 3,200, we will equate this one to 0. Negative 16x plus 3,200, using the addition property of equality, we have here 3,200 equals 16x. By symmetric property, we have here 16x equals 3,200. Using the multiplication property of equality, we will multiply it by 1 over 16. So our x is equal to 200. Since the profit function is continuous and we have an interval with finite bounds, we can find the maximum value by simply plugging in the only critical point that we have, which nicely enough in the range of acceptable answers, and the endpoints of the range. Let's start with 0. We will plug in 0 to the profit function. P of 0 is equal to negative 8 times 0 squared plus 3,200 times 0 minus 80,000. Now, if our x is equal to 0, then our P of 0 is equal to negative 80,000. How about if our x is equal to 200? Now, let's plug in 200 to our profit function. P of 200 is equal to negative 8 times 200 squared plus 3,200 times 200 minus 80,000. If our x is equal to 200, our P of 200 is equal to 240,000. Now let's have here the 250 as our x. This is the maximum of our range. Now 250, we will plug this one to our profit function. P of 250 is equal to negative 8 times 250 squared plus 3,200 times 250 minus 80,000. So if our x is equal to 250, then our P of x or our P of 250 is equal to $220,000. So it looks like they will generate the most profit if they only rent out 200 of the apartments instead of all 250 of them. Note that with this problem, you should not just assume that renting all the apartments will generate the most profit. Do not forget that there are all sorts of maintenance costs, and that the more tenants renting apartments, the more the maintenance cost will be. With this analysis, we can see that for this complex, at least something probably needs to be done to get the maximum profit more towards full capacity. This kind of analysis can help them determine just what they need to do to move towards the goal, whether it be raising rent or finding a way to reduce maintenance costs. Note as well that because most apartment complexes have at least a few units empty after a tenant moves out, and the like, that it's possible that they would actually like the maximum profit to fall slightly under the full capacity to take this into account. Again, another reason to not just assume that maximum profit will always be at the upper limit of the range. That would be all for an example of business application. Thank you so much, and God bless us all.